Hello. My name is Emery. Welcome to Coding Australia. This project is called Clock.
So this is the next part with the clock. We're going to well, this first video will run through the Scratch clock, even though there is other places that we've done the clock. This one is slightly different, so we'll just work through it because we're going to compare how this one looks in Scratch to how it actually looks in Canvas, and we're going to build the project up quite a bit as well, and in the end we're planning there'll be an analog clock and a digital readout as well. Now I know that some of the other Scratch ones have got digits as well, but this one's going to be a little bit different, and we'll build it up in both as we go. So first things first, a lot of what's happening here is exactly the same as what's happening in the other clock projects that you'll find on the Scratch page. Now down here, I think I'll just rename these because you'll see why. I'll call that one hours, and I'll call this one, well, I can call it minutes or seconds. I'll call it minutes, plural, because we've already got second, minute, hour, hands. Now we've got hours and minutes. So hours, numbers 1 to 12, and minutes and seconds under 60. And the clock face slightly different, just used a bit of gradient there, that's all. And the scripts start with the outside of the clock, then it goes to what we'll now call hours. Alright, so we'll call it hours. That gives us this one over here. So when I receive hours, then we'll go to minutes. So minutes. So then we'll go to minutes, and when I receive minutes, we'll then broadcast hands. And of course, if you go and look at the other ones, you'll realise that hands goes to lots of places there, 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 and there. So it broadcasts to 4 different places. Now let's see what it does. The outside of the clock, the hours, the minutes, and then the clock itself. Let's have a look at how the hour scripts work. So nothing's changed here from the original clock ones that were done in Scratch, or not much anyway, a little bit maybe, but not a lot. And the good thing is that you can just duplicate this to here, and it pretty much does the same thing, except it sets the size to smaller, and other than that it's pretty much the same. I just might restore it when we go back in case there's a problem. So when we get to hands, it does the same thing it's always done, and as you can see, it just keeps running. So these three go forever while the clock runs. Now in the next video we'll go and see what it looks like in Canvas. Alright, so now we're over on Canvas, and we're going to do the same clock, very similar. As you can see here, here's the actual clock itself. It doesn't have any numbers yet, but it will. Over here is the code. I've actually commented out the bits that aren't showing yet, so that we can just slowly work our way through. So first things first, nothing much going on up there. It's pretty basic. 600 by 600, the truncated, the translated. So we've got to translate, and it's gone up the page a little bit because the end result of this project will be a digital readout sitting down the bottom here of the 600. So there'll be a digital readout there as well. So we're just thinking slightly ahead here. So that's why that sits up. The radius is just reduced a little bit, so it's sits inside the 600. Right, now what happens is that the way a clock works, and the way lots of games work, is that it refreshes itself over and over and over again, and that's the statement that does it. So set interval, draw clock, 1,000th millisecond. So it refreshes itself quite a few times per second. It sets this is what it looks at. So that's calling this function here, and this function here is calling these three functions here. So draw clock calls up radius, draw face, passing the radius value, numbers passing the radius value, and time. So the radius for the face is, this is what it looks like. This piece of code here gets you that, and it gets you to you how? Well, you drawing circles, which you've seen before. So that's your outer, that's your white space. So if I change that colour, for example, I'll show you what I mean, but I'll put it back. But if I did this and saved it and then ran this, there you go, you can see what it's doing. Okay, so I can leave it like that for the moment. And this is a gradient, which we've looked at elsewhere as well, but not quite the way this works. Very clever. Grad, there's a statement to have a look at. Create radial gradient, very handy. Very powerful stuff with Canvas. So we then do what are called colour stops, and anything between 0 and 1 is valid. So to get the three bits of colour, which are the pink or the red, reddish, white and green, you can see if you know your RGB. So there's your green, there's your white-ish, and there's your red. You put all those together, and then your stroke style takes the grad variable as its value, line width, stroke, begin the path, and then this little one here and that there. So it does the exterior, and then it does this, but that's this bit here in the middle. Alright, so there's your clock. Now let's have a look at the numbers. So we'll refresh, and the numbers appear, very similar to the Scratch project. The way the numbers work is there are two loops. So if you think of those two broadcasts that went through on the two different sprites for the numbers, this is doing a similar thing, although it's a bit clever. It's one thing this does, which I couldn't figure out how to do it in Scratch, so I didn't bother. But what happens here is you don't actually have to use anything like numbers themselves. You can create them by doing this. First of all, the fill style is going to be black. You need these here at the top. The font size and style is going to be 30px Arial, and then you're going to do a loop, 12 loop, 1 to 12, 1 less than 13. Rotate, go to a spot slightly under the radius, and then do this num, which is this 1 2 3 4 5 6 7 8 9 10 11 12 to string. Rather neat. And then it puts those numbers where you tell it to put it. So they're the big ones, and then the second one, which is exactly the same except the radius is slightly closer to the edge. There's 30 here, not 6. It goes 61 times, so it goes to 60, and everything else is pretty much the same, and as you can see it's smaller. So that's how you get the smaller numbers sitting there like that. So there's your clock and there's your numbers, and in the next video we'll have a look at the time. Alright, so this is how we left it off, and now the next part we do is the actual time itself. So we'll uncomment time, save it and run and see what we've got. Okay, so there it goes. Now let's go and examine what's happening here. Draw time down here. Draw time. So some declarations at the top, and what happens is, as you remember, this thing refreshes 1,000 times a second, so, or 1,000 milliseconds, and so it just keeps getting off the computer what the time is. It's the same, similar thing to the way Scratch works, where it just grabs the computer clock time. So as long as if the clock time on the computer is right, then the clock itself will be right, and so that's how it works in Canvas. Those are the statements there. All right, and then we have three things happening, and they're kind of similar. First of all, the stroke style, black, bluey red. It's for hour, minute and second. Then a little calculation here, because it's a 24-hour clock. This is a mod statement. Okay, so what happens is that the hour will the remainder of the hour will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When it gets to 13, it'll go back to 1. So that's how that one there works. And then we have this calculation here. Now that there is very similar to the scratch one, where it actually gets the time, and there were some little calculations where we had to realize that there may have only been 12 numbers, but it actually had to go around 360 times, which is why you do these little calculations here. That's a bit overblown, that bit, but that's alright. That's just so people can see what's going on here. So that's how you get the hour doing its thing. So it recalculates every time it refreshes, then it goes and draws it. Now if we go to minute, same sort of thing. The minute calculation, have a look at that, how the second works. So there's a second, they're the same. So you get a very smooth movement. And then the minute, and draw the hand for the minute. And then the second is just a straight out calculation of the second divided by 30. Because when you get the second, there, what you want it to do is you want it to go around like 60 ticks. And so that's how this thing here works. Alright, and you draw the hand. Now, there are three parameters that are passed across, three values that are passed down to where the drawing actually takes place. So hour, radius and 15. So the hour is the value of the hour, the radius times 0.5, 0.8 and 0.9. So that's a fairly short hand. That one's a bit longer and that one's the longest of the lot. And these are the widths. Okay, so that's the widest, narrower and even narrower. And if you have a look here, that's the values: position, length and width. Comes down here, sets the line width, rounds the edges, moves to the 0 spot, does its little rotating position that you need, so the position here, alright, and then it puts the line in, and it just keeps doing that over and over and over again. And so that's how you get these three things doing their thing based on those calculations, those three that go to this function and then do the drawing. And that's how it works. So that's the first part. That's the analog clock. So we're going to switch back here to the Scratch project of the analog clock, and we're going to add a digital readout, a fairly basic one to start with. To do that, we'll create three variables called second, and minute, and hour. And we'll change them to large readouts and put them over here somewhere. This is as good a spot. So make them large readouts, put them here like so, hour, minute, second. And then what we'll do in each one of these, so with second we'll just put set second to duplicate current second. There it goes. Same thing for minute. Set minute to current minute. And there's the minutes. And set hour to now it doesn't need to move, so we're just going to use the current hour. That's all we need here for the digital readout, like so, and that's it. So it keeps getting the current time, current hour, and it does that. Alright, now we can leave it like that. Looks good. The only other thing we can do is with digital readouts, sometimes when the numbers are less than 10 they have what's called a leading zero. So here for example, so if you want to do that, what we can do is this. We can use a statement like this. If the hour is less than 10, then set the hour to join 0 and hour, like that. So we'll put one over the top of a minute so we don't have to do them much again, and we'll put it there, and we put that in there like so. Now it's not going to show you because it's greater than 10, but when we get over here, same story, we'll use a minute. So if the minute, do that, and over here, oops, if the second, ooh, back here for a minute, that's what I thought, that's got to be minute, right, that's more like it, second to join second, and put that in there like that, and we should be right. So we set the second to the current second, and at the moment, looking at it, I can't tell if it's working or not. I'll just make sure everything's right. Minute, 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 minute. It is, and hour, hour, hour. Join hour. So that one's working as well. So that gives us a really basic digital readout, and one of the videos further on, what we'll do is we'll actually use those flip type numbers for our digital clock instead, which is a bit more effective. Let's see if our leading zero is working. So there it is. Yes, it's working. That's good. So that's the second doing its thing till it gets to 10. Good. So here we are back over at the canvas clock, analog clock. That's what we were left with. This is the script that we worked with before, and what we're going to do now, what we'll do is we'll add a digital display down here. Okay, so to do that, we'll just create another function and put it in that spot and get the numbers and put them there. So how we're going to do that is, everything's the same. What I did was I've changed that to analog instead of time. So this is now the analog call up, and I've added another function called digital, and that's the new part. Nothing else changes up the top. It all happens in its own separate function. So underneath all this is this. Okay, let's go through it. I've used a very similar structure to what happens up here, so you could copy and paste a lot of this and then just make the changes. So I just used a different name here so I could keep track of what I'm up to. So did you get hour, did you get minute, did you get second? Now I've changed this to got hour, got minute, got second. Now there's a reason for that. I've also got a variable called colon, which we're going to use. So here's the got hours divided by 12, percentage modular 12, so that it goes 24 to 12. Now here is how the leading zeros are done, which are rather neat. Standard method to how to change a variable. It's quite compact. If it's less than 10, do the first bit, otherwise do the second bit. So if it is, stick a 0 in, add it to got hour. So string them together, string them together, string them together, otherwise leave them the way they are. So that redefines hour, minute, second, and since we're doing them milliseconds, it's just jumping from one function to the other, so they don't get in each other's way. They're like global variables, kind of. Okay, now it says here the digital area. Alright, the digital area is here, and what have we got? Play with this if you want, but that sort of puts it in about the right spot. We've got the actual rectangle, so what we want it to look like, what we want, how big we want it, where we want it. So that is going to draw us a rectangle with a yellow background around a red border. That's good. Down here we've then changed to a sort of a dark blue. Our font is bold, 40px Arial, so the bold's a bit new. All that other stuff's exactly the same. And then we put in our digital numbers. Fill text out to string in that spot, the colon, the minute, the colon, the second, in those spots. Okay, all these numbers sort of match each other. You just play around with those numbers to get them right. That's what I did till I got it positioned exactly where I think would be a good spot. Alright, so if you get all this happening and there's no mistakes, you will finish up with that at the bottom. And as you can see, it's ticking over beautifully. And the leading zeros do work because I've checked them. And that's it. Okay, so now we're going to do a digital clock using some images, flip images, which you need to go and get, and I'll just show you what you need to get straight away to do this project. This is the one I got. It's called flip clock or something. I've called it digit clock, and I've saved it in an images subfolder, and as you can see, it's quite big. It's only showing at 41%, so these numbers are going to determine what happens in the actual code that you write. So you've got to keep a note of those, otherwise it won't work properly. So what we've got here is 10 digits. It's 2635 wide, which means that if you divide that by 10, each one of these is about 263 wide and 451 high. So that's the first thing. And over here we will have a look at this. I'll just recap briefly because I've got to show something. There's a slight bug that I picked up, and it happens when you're trying to test these things. Some things get overlooked, and this one has been overlooked, and it happened by pure luck that we ticked over to 12 o'clock while I was doing this, and that showed up a little problem, because what happened was in here, and it'll affect the previous project as well, if you just leave that as the original got our divided modular 12, when it goes to 12 everything shows up as 0. So instead of having this, you've got a pair of zeros. So you need to check that it's greater than 12 to do it, otherwise it just stays as a 12. Alright, so that's just a little bit extra that needs to go in there. You'll have to go back and change the other one as well, and that will fix it. And then the rest is as we go. So display numbers down here, very similar to what we had before, a little bit bigger. And the other thing is that there's no translate, so we're not translating to the middle, so we're top left hand corner again. We're back in the top left hand corner, so all these positions are relative to the top left hand corner, and how you use these numbers and how you set them up is up to you. Got a blue with a green and a red, sorry, a red and a yellow box. So over here, that's what we've got. Okay, so that sorts out the number string in the numbers with the colon in between. Alright, we didn't pass any variables through any of this stuff, which means that has to go in here, because if you put it up there somewhere it doesn't pick it up unless you want to pass it down here, which you can, but the colon goes in where it actually is needed. So that's the first part. Now let's go back and examine the second part. I'll just uncomment that for a minute. So what's happening up here? Well, remember I said 451, 263, so there's the numbers you need for your digit height, and they're in capitals, so they're easy to spot. They don't have to be in capitals, just easy. These are the three statements you need to get things happening. It goes and finds this image, and if it loads it successfully, it does the rest. Here's your little refresh, 1000 millisecond thing that happens, same as before, and then it goes down to time. And this time, instead of like in the one before with the analog and the digital, where they were separate, the times were got separately. They didn't have to be, but they were. This one, it only needs to be got once, and then it goes and draws the numbers, which we just went through, and then it draws the images. Now, the way it works is this. It says this if you're not sure about this, go back and have a look at how those 4 dots are painted in the dot one, because this is exactly the same, except, or it uses the same method. It's just that it looks a heck of a lot more complicated, but it's only using digital width and digital height to get the job done. So this first part, we're going to do the hour. So hour, whatever the value of the hour is, put that in, times the width of the ditch, 263, in that position. So it picks up that section of the image. So it might be picking up the 5 or the 10 or the 6 or the 9, whatever. This will tell you which one it's picking up. Okay, this will tell you how big it has to be, and this will tell you the position that they're going to be put, and this is actually reducing it by a third its height. And the reason for that is that if you go and actually look at the full size of that PNG file, those numbers are massive. They're like about this big. So if you reduce them to a third, they get down to a much more manageable look. Or you can just go and make the actual thing itself smaller if you wish, but that just shows you how things work. It's good for restretching and stuff, so it's nice to know that kind of stuff. So there's your hour, your minute, and your second. And over here, when we refresh it, there they go, flipping away. So goes here, picks it up, picks it up, picks it up. Also picks up the leading zeros as well, which is what you want. And this time for sure it's working. I might have said earlier that I thought it was working, but that was the bit that was a bit of an issue. So you need to go back and just make that little change in here, and you'll be in good shape.
Thank you, too.